Hey guys, welcome back. This is Bimzycodes, and in today's lesson we're going to be looking at implementing some difficulty progressions into our game. So what that means is we're going to be replacing all of these droppable objects in our game scene with one object that's going to be spawning droppables on the fly, and we're going to be increasing the rate at which these droppables are being created to create some difficulty for our level. So as you play the game and as you progress, the blocks will start falling faster and faster until you inevitably lose the game. The first thing we want to do is disable this droppables game object. If we click this, go over here on the right hand side and just click this tick box, untick it, you'll notice all of the droppables have disappeared. These droppables are now no longer active in our game scene. The next thing we want to do is create a new 3D object, and let's create a sphere to represent the droppable spawner. So I'm just going to rename this one to Droppable Spawner. And now let's reset the position of that. Just move it into position. I think the Z was 10 to align it up with the player. Now let's move this one up off the screen. So this droppable spawner is going to create droppable objects on the fly and sort of drop them in line with the player along its horizontal axes. Let's make a script for our droppable spawner game object. So create C# script, droppable spawner. And now we can just drag that script straight onto the game object. Alright, just save the scene quickly, and we can jump straight into the code. What our droppable spawner class is going to do is create the droppable objects that are going to be falling from the sky. So to do this, let's create our first variable, the public game object, droppable. So when we go back into our Unity scene, we can actually drag one of our droppable prefabs onto this, and that's the droppable we're going to be creating. Now to actually create the droppable object, we want to use a method called Instantiate. So what Instantiate means is we're going to be creating or cloning the prefab that we pass into this method. So the first parameter that this would take is this prefab that we're going to be cloning. So we're going to pass in the droppable here. The second parameter is the position. So let's take our transform and pass in the position. The third would be its rotation. So let's pass in a quaternion dot identity, which essentially means we're just copying the rotation of this current object. And then finally, let's pass the parent, the parent transform, which would just be this droppable spawner game object as the parent. So that means when we create our droppable, it's going to be cloned straight into our droppable spawner game object. So this should now work for our game. So let's go back into the scene and test this out. When we hit play here, we should see a game object fall. Unfortunately, we're seeing an error instead. So what we need to do to fix this is go back to our droppable spawner game object here, and we actually need to drag the droppable into the game object slot. So let's put an obstacle down first for now. So when we hit play again, we should see this obstacle falling from the sky. Now we only see this obstacle falling once. That's because we've created our instantiate in the start method. So we're only ever calling this instantiate once. To fix this, we're going to want to create a timer. So let's create that variable for our timer by creating a private float timer. Now let's just set that one to 0, even though by default its value should be 0. I just like to do that for good practice. Now when we go into our update method here, we want to add the delta time each frame to our timer. So we can do that by doing plus equals time dot delta time. Now to visualize this, let's put a debug log in here so we can output the result to our console. And let's grab that timer, copy, paste that one in there. Now let's test this one out in the scene. Just have to wait for it to recompile. And when I hit play, we should now see in our console that our timer is being printed out here in the bottom left. Or if we go to our console, we can see every frame. We're updating the time of our timer. So that's working as intended. Let's jump back into the code. So for now, let's create a new droppable game object every 1 second. To do this, let's create an if statement and check what the timer is against the time that we're looking for. So if the timer is greater than or equal to 1 float, we want to be creating our droppable here. So let's just grab this snippet of code, instantiate, throw it straight into the if statement. And now before we forget, let's reset the timer back to 0. Because otherwise, if we don't reset the timer, once we hit this if statement, we'll be hitting it every single frame and we'll be instantiating the droppable every single frame. So let's just reset that one to 0 floats so the timer resets and restarts. If we jump back into our game code, or into our game scene rather, we should be able to see a new droppable game object being created every second. And that's working as expected. So the game's sort of coming together and looking more like a game. The next thing we want to do is create a horizontal offset for the droppable game object to be spawned at, so it's not always falling straight in the center of the screen. So to do that, let's jump back into our code and let's create the x offset variable. So public float horizontal, or let's call it horizontal offset. So horizontal offset. So we want to grab this piece here and let's just set that one to 10 for now. I think that's a pretty good number. So every time we create our droppable object, we want to find a random position based on this current transform position and the offset that we pass in to instantiate the object at. So for now, let's create a new float called x offset. Now I call it x because x is the axis that represents horizontal. Equals, now we're going to use this random method, random.range, which will essentially output a random value based on the range that we pass in. So we can give it a minimum value and a maximum value, and it'll give us a random value between those two numbers. So our minimum is going to be negative horizontal offset, and our maximum will be horizontal offset. So with this x offset variable, we want to add that to the transform position. So to do this, we do plus new vector3, pass in our x offset for the x, 0 for the y, and 0 for the z. Now this should be working as intended, so let's jump back into our game and test this one out. So that's looking pretty good. One thing I'll notice is the range being 10 doesn't actually account for these edges of the screen. So let's quickly find out exactly where that edge would be. So if we want to move our player to the left-hand side of the screen, we can sort of see the player's X position right on the edge there. So by the looks of things, I think negative 22 and 22 might be the range of this camera's perspective. So let's just go ahead and update those values in our droppable spawner. So we want to go to droppable spawner, update horizontal offset, and I'm just noticing now actually that it might be better for us to bump this camera up a little bit just so the player's right on the bottom of the screen. That'll give us the best reaction time to actually move out of the way of the obstacles. So I'm just going to do that now. And if we run the game, we should see the obstacles falling across the entire width of the screen. Perfect. This works as intended. That's the end of this lesson. But as you can see in our game, there's no difficulty level. Because we can potentially infinitely keep dodging these obstacles, the game will never end. So in our next lesson, we're going to get to adding a progressive difficulty and also adding all the obstacles that will give us score to collect. So I'll see you then.